Section 24 is entitled The Least Common Denominator, also known as the LCD. In my opinion, there's no difference between the LCD, or finding the LCD, and finding the least common multiple, which is abbreviated LCM. LCM. Multiple kind of has the word multiply in them. So you need to multiply to find the LCM or the LCD. If you are asked to find the LCD for some problem, like 3 over 5 plus 2 over 7. What they are asking you is to find the least common multiple of the two denominators. Assuming you can't reduce the fractions. If you can reduce the fractions, get smaller denominators, and then find the LCM of of the two denominators. Find the LCM of 5 and 7. I guess what I should write is this. So they didn't really ask us to find the LCM. The LCD of 3 over 5 plus 2 over 7 is the same as the least common multiple of 5 and 7. Multiple. We have to find common multiples of 5 and 7. We multiply. Multiply. Most people don't try to multiply. They'll say the least common multiple of 4 and 6 is 2. Because 2 is the least number that goes into 4 and 6. At least that's what they think. If that was the rule would be 1. 1 is the smallest number that goes into 4 and 6. We're trying to find factors. It's not what we're asking. We're asking for multiples. You must multiply. I can't stress that enough. 5 times 1, 5 times 2. We write down the 5 times table. 25, 30, 35, 40, 45, 50, 55, 60, 65. We'll stop at 70. Those are the first 3 multiples of 5. Some multiples of 7. 7, 14, 21, 28. You have to know your times table. Don't know your times table, this is going to be brutal. It's going to take you 4 times longer to do your homework. You'll never get good at it. You'll get poor grades. And again, you're spending twice as much time on your homework. You don't want to do that. You want to spend less time on your homework. Learn your times table. We want the least common multiple. I like to think of it as the first common multiple. 70 is a common multiple. They're under multiples of 5 tables, and it's also on their 7 times table. But you know what? It's not the least. 70 is a common multiple. So we want the least one. And we look again, the first number that's on both lists is 35. So this equals 35. The LCD of this sum is equal to the LCM of the two denominators, which is 35. I can't stress it enough. The word M is there for a real reason. They want you to multiply. If you were asked to find the LCD for I don't know, 7 over 6 plus 2 over 9. Well, that's the same as the least common multiple. Since you can't reduce this fraction or that fraction, I'll find the LCM of those two denominators, 6 and 9. You write down the 6 times table, or at least the beginning of the 6 times table. You write down the beginning of the 9 times table, 9 times 1, 9 times 2, 9 times 3, 9 times 4. 36 is on both lists, but 18 is also, and it's the smallest number on both lists. And that is our answer, 18. You just make the look at the multiplication table, the times table for the 6 and the 9, and you look for the smallest number on both of them. The concept is very, very simple. If this is hard for you, there's only one reason it's hard for you. That's because you don't know your times table. Okay, what if I ask you to find the LCD for these two fractions? 71 over 14 plus 11 over 42. Well, this is equal to the LCM of the two denominators, because we can't reduce them. Just write down the 14 times table. There are other ways of doing it. I'll do this one slightly different next time. That is, I'll do it twice. The 14 times table. Now, you know the 14 table. 14 times 1, 14 times 2, 14 times 3. I'm going to stop right there because I may not be an expert on the 42 times table, but 42 is on the 42 times table. 11 is on the 11 table. 12 is on the 12 table. The first number on both lists is 42. Another way of doing this problem is to use factor trees. Find the prime factorization. Well, let's get rid of the whole last problem. You want to use factor trees. That is another way of doing this. Okay. Find the LCD for 71 over 14 plus 11 over 42. And that's going to equal to the LCM of 42 and 14, or 14 and 42. So we did it one time. We wrote down the product. That is the multiplication table. We found the smallest number on both. So 14, for example, well, that's 7 times 2. 7 to the 1 times 2 to the 1. 42, well, we just learned that it's 14 times 3. This was 14 times 1, 14 times 2, 14 times 3. Okay, 3 is prime, 14 is not. It's 7 times 2. So 42 is 3 to the 1 times 7 to the 1 times 2 to the 1. Now, the LCM of 14 and 42, you write down all the different prime numbers, bases that came up. Prime numbers 7, 2, 7 times 2 times 3. I already wrote down 7 and I already wrote down 2. There's the 7, there's the 2. Then we do one more thing. Between here and here, I look for the highest power of 7 that came up. Well, there was only one power of 7 and one different power. The highest power is 1. Between 1 and 1, 1's the largest. 2. The highest power, I look at the powers of 2, 1 and 1. The largest one is 1. I look for powers of 3. The only power of 3 I see is 1. Well, that's the largest one. So the answer is 7 times 2 times 3. Yes, this looked like a lot more work than what we did here, just because the numbers were pretty small. I only use this when the numbers are somewhat big. I won't do 7 times 2, which is 14, because I don't know my 14 table. Although, we don't know the 14 table. So I'll multiply 2 times 3, which is 6, and then I'll multiply 6 by 7. That I know. I didn't get beyond 10. To know up to your 12 table. Well, here I didn't go past 10. 7 times 6. Try it out though. Suppose you want to find, or you're asked to find, the LCD for 7 over 300 plus, I don't know, 11 over 90. You should look to see if you can reduce. If you can reduce, do so. Get smaller denominators. Well, this is going to equal whatever the LCM of 390 is going to be. This denominator and that denominator. Well, we can do the times table, but I think that's going to be harder. Let's try the prime factorization method. 300, well, it's 3 times 100. 3 is prime. It'll be 3. 100, why, that's 10 times 10. The 10s are not prime. They're 2 times 5. But that's prime. And 2 times 5 is prime. So we have 3. Then we multiply by 2 2s. We put a 2 in the upper corner to say we're multiplying by 2 2s. And we're also multiplying by 2 5s. If you don't like the powers, well then just write it down this way. Now let's go to 90. 90, 9 times 10. 9, 3 times 3. 10, 2 times 5. Each of these numbers that I just circled, they're prime. So, we get 3 squared times 2 times 5. And the power is understood to be 1 if it only comes up one time. If you don't like exponents, fine. It's 3 times 3, those 2 3s, times 2 times 5. Times 2 times 5. Now, the LCM is going to equal, you write down the different bases. 3 or 2 or 5, you can look here. 3, 2, I already said 2, 5, we'll look here and get 5, 5s again, 3 I already put, 3 I already put, 2 I already put up here, and 5 I already put up here. Okay. Now, between, depending upon which one of those two you want to look at, between these two, you write down the highest power. 3, let's do it 2 times. 1 using the powers. 900 for the 90. 390. I'll change it. Well, the different powers were 3, 2, and 5. Between here and here, the highest power of 3 is 2. We have 1 and 2. Highest power was 2. The powers of 2. 2 and 1. 2 is larger. The powers of 5. 2 and 1. 2 is larger. This is 9. This is 4. 5 squared is 25. I wouldn't dare multiply 9 by 4 because I know what 4 times 25 is. It's 100. It's a very friendly number. 100 times 9 is 900. Okay. Let us do it again without using powers. If you don't want to use powers, don't use powers. we're going to look at this representation for 900 that we got from the factor tree, and this 300, and this representation for 90. So the LCM of 390 is going to equal, well, I see 3 2s and 5s. I have 1 3 here, and I have 2 3s here. The 2 3s win, they're more. I have 2 2s here, and only 1 2 here. 2 2s are the winner. I have 2 5s here, and 1 5. Always pick the most, which are 2 5s. Well, 2 times 5 is 10. I love multiplying by 10. In fact, I have another 10. 10 times 10 is 100. And that's 9. 9 times 100, or 100 times 9, 900. So, did it two ways. One with powers, one without powers. I bothered to do it without exponents or powers, because we didn't really talk about them yet. Okay, we're going to try one more problem, and that's going to be 31 divided by 1575, and we want to answer 13 over 490. And the question is to find the LCD for this. Well, that's the same as finding the LCM of the denominator. There's no real difference between the two. Now, you really don't want to list down the 1575 table. You don't want to list the 490 table. You might have to list the 1575 table for 490, the first 490 numbers. And if you think that's bad, you might have to list the 490 table for 1575 numbers. You don't want to do this. You don't want to do this. You want to use the factor trees. You definitely want to use the factor trees. Well, let's put it a little higher. I guess I should have given the rule the divisibility rule for 25. The divisibility rule for 25 is if the last two numbers is 00, 25, I meant to say 50 next, excuse me, 75. If it ends in any of those four numbers, then it's probably better to put those first. Put 50 first. 00, 25, 75, or 55. 25 goes into this number. So when I do the division, I'm not doing it blindly. I know it's going to go in. And 6 quarters, 625 is 150. From 157, that leaves 7 left over. 25 into 75 is 3. So it wasn't that bad. 25 is not prime, but 5 times 5 is 25, and those are prime. 63 is 7, which is prime, times 9. 9 is not prime. I didn't mean to circle it. 9 is not prime. It's 3 times 3, and the 3's are prime. Okay, so we have that. We have that 1575 is 5 times 5 times 7 times the 2 3's on the bottom. Okay, that's done. Took a lot of space, but it's done. Let's do 490. Since we know We know that 10 goes into 490. It goes in 49 times. 10 is 2 times 5. Those are prime. And 49 is 7 by 7. So we have 7 times 7 times 2 times 5. So the LCM of 1575 and 490 will be, well, the different numbers are 5, 7, 9. I already said 7. I didn't write 2 yet. I already said 5. Okay, question is how many 5s? How many 7s? Well, on the left, we have 2 5s, and over here on the right, we have 1 5. So the 2 5s win. 7s. We have 1 7 here, 2 7s here. The 2 7s win. The 9s. I have 1 9 here and none to the right. So the 9 wins. 2. Of course I blew that. There is no 9. Actually, I don't know why I'm not looking here and here. Sorry about that. Let's just start this again. Sorry for the delay. Okay. I see 5. 2 5s here and 1 5 there. The 2 5s win. Then I see 7. 1 7 here and 2 7s here. The 2 7s win. Then I see 3. 2 3s here, no 3s to the right. The 2 3s win. Then I see 2. The answer is this product. The answer is this product. 25 times 49. This is 9 times 2 is 18. You can multiply those 3 numbers and you get the answer. A lot better than writing down the 490 times table. And then after you do that, you now have to write down the 1575 table. And hopefully you go out far enough. 49 times 25. 5 times 49 is 245. And then 2 times 49 is 98. 5, 12, 12. 1225. That's what you get when you multiply those two numbers. Now I have to multiply it by 18. 9800. 1225 times 8 is 9800. You know that. And then 1 times 1225, why? That's 1225. And when you add these numbers, you get 22,050. And that's the answer. 22,050. You're going to have to write down the 490 table an awful lot of times before you get 490. I can tell you how many times. 7 times 7 is 49, and 5 times 2 is 10. 10 times 49 is 49. So you're going to have to multiply 5 times 3, 15 times 3, 45. You're going to have to write down the 49 table, 490 table for the first 49 numbers. What is 49? 45. 490 times 1, 490 times 2, all the way down to 490 times 45, which is 22,050. You don't want to do that. You really don't. And then you're going to have to write down the 1575 table. That's the alternative, doing it that way. Okay, one more problem. The going to be slightly different, but not much. And so maybe we'll do two more. Suppose you want to add or subtract three fractions. What if you have 1 over 9 plus 1 over 21 plus 1 over 14? And you want to find the LCD for that. Well, this is going to equal the LCD of 9, 21, and 14. Like always, there are two ways of doing this. You can write down the times table. 9 times 1, 9 times 2, 9 times 3, times 4, times 5, times 6, times 7, times 8, times 9. You can write down the first three multiples of the 21 table. 21, 42, 63, 84, 105, 14, 28, 42, 56, 70, 84, 98, 112. Well, let's see. I see 42 is common, but it's not in the 9 times table. You would actually have to go out further. 90, 99, 108, 117, 126, 135, 144. Let's see if that's far enough. 126, 147, 168, 168, 189, 210, 231, 252, 273, 126, 140, 154, 168, 182, 196, 210. Well, 210 was on both lists. Just make sure it was the first one. '84 was on these two, but they weren't on the 9 times table. 98, 126 should be on all three lists. 120 on two lists. 126, and it's on the third list. So the answer was 126. That's the answer. The answer is 126. An easier way of doing it is to say that 9 is 3 times 3, prime numbers. 21, that's 7 times 3. 14, that's 7 times 2. The LCD, the LCM is going to equal, well, first I see 3. 1, 2 3s, 1 3, no 3s. The winner is the 2 3s. Then I see 7. No 7, 1 7, 1 7. The 1 7's the winner. Cross off the 7. Then I see a 2. No 2, no 2's, 1 2. The 2's the winner. 9 times 7 is 63. Times the 2, 126. A lot quicker. Sorry about that. Okay, and that finishes the section on finding the LCDs. That is, finding least common multiples. Okay, do a lot of work with this. They're not easy. Good luck.